In episode 19 of the CySec101 training series, we are going to go through the TCPDump tool, the basics of the TCPDump tool, which is a part of the networking module in the Cybersecurity 101 pathway of TryHackMe. And this is our second to last room to finish up the networking module, and the next one that we have is on Nmap, and then we get to go into cryptography and exploitation and all the other fun stuff. So today we're just going to be jumping into the TCPDump tool. This video has been brought to you by the Hackaholics Anonymous membership community, which is the premier YouTube community for security professionals and hackers. And to get access to a bunch of perks like Python automations, Discord servers, exclusive content, early access to content, exclusive downloads, live streams, and a variety of other things, I do encourage you to check out Hackaholics Anonymous. You can join through the link in the description below, or you can go to our homepage and click that join button, or you can simply go to youtube.com/@hankhackshackers/join, and then you'll be able to join the community. Now, without further ado, let us jump into the TCPDump room. Okay, so the main challenge when studying networking protocols is that we don't get a chance to see the protocol conversations taking place. Now, conversations is just a back and forth that goes on with various IP addresses and ports and interfaces and so on and so forth. And we refer to those as conversations, us in the nerdy tech community of cybersecurity. So anytime that two different machines, it could be your cell phone or your laptop, it could be a server and somebody's client, which would be their computer. Anytime that there's an interaction that takes place between two different nodes, that is called a conversation. Now, all the technical complexity are hidden behind friendly and elegant user interfaces like what you see right here. This is an actual user interface. But if we went to look at the source, right, if I clicked on inspect right here and actually looked at the source of this page, it is not so friendly because there is so much code out behind the scenes right here that we don't even know what's going on. And this is not even what we're talking about when we're talking about conversations and all the different things that goes on. So there's a lot of stuff going on under the hood, so to speak. And you don't really see all of that because it's all hidden behind beautiful, elegant little user interfaces, right? So you access resources on your local network without ever seeing an ARP query, which is the address resolution protocol. Similarly, you would access internet services for years without seeing a single three-way handshake till you check a networking book or inspect a network traffic capture, which is what TCPDump actually is. And we did Wireshark in the last video, so you got a chance to check that out too. So the best study aid would be capturing network traffic and taking a closer look at the various protocols, and this helps us better understand how networks actually work. Now, this room introduces some basic command line arguments for using TCPDump. The TCPDump tool and its libpcap library are written in C and C++, which are actually relatively easy to wrap your head around. I would say they're not as easy as Python, but they're not as complicated as, I don't know, what can we say? Like maybe JavaScript might be a little bit more complicated than C or C++. So they were released for Unix-like systems in the late 1980s, which is like literally the infancy of computing, or the early 1990s. Consequently, they are very stable and offer optimal speed. The libpcap library is the foundation for various other networking tools today. Moreover, it was ported to MS Windows as WinPcap. Now, the objectives for this room are to capture packets and save them to a file, set filters on captured packets, control how captured packets are displayed, and of course, we're going to be using the wonderful TCPDump tool. The prerequisites are everything basically that we did at the beginning of this module. So there are episodes for every single one of these. So networking concepts, essentials, core protocols, and secure protocols. All of those are already live inside of the CySec101 playlist that is on this channel. So I highly encourage you to check those out if you haven't done so already, because there's some good essentials and core concepts and stuff that you really do need to at least be familiar with, because I don't think we're going to be going into the the foundational stuff, the fundamentals in this video. We're more so going to be using the TCPDump tool. So if you don't know them, you probably need to know them. That's why they're called prerequisites. Now that being said, we actually have our virtual machine that I already clicked on, and it's already started. That's this beautiful black screen that you see on the right. That is not so much an elegant interface. That is just a pure command line interface. It is a Unix system, a Linux system, I should say. It is a Linux system, Ubuntu 20.0.4, da 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 da. This is usually what it looks like when you go like connect to some kind of a server that is inside of a massive environment, and it hosts a bunch of different computers and a bunch of let's say web servers and databases and so on and so forth. This is what it looks like. You really don't get a GUI, a graphical user interface. You just get a command line. So at the very least, if you don't know how to run some basic commands on Linux, go check out all of the Linux fundamentals videos that are on the channel. Go check out the Linux Plus videos. It's like a whole playlist that I have for Linux Plus. And then there's, of course, the most popular video that's on this channel, which was, you know, become a kick-ass Linux administrator. That video ended up kind of blowing the channel up. It was like the very first, like, I guess you could say, viral piece of content for relative to this channel, at least, right? It's not, it'll probably ultimately hit 1 million views, but I think it's like over 100-something thousand right now. So that is, you know, that's available if you haven't checked it out, and if you don't know how to use Linux, because I'm not going to be explaining all the stuff that you need to do with Linux either. So first question is here: what is the name of the library that is associated with TCPDump? And that is libpcap. And then we press enter, and that is our answer. And we have officially gotten our first correct answer and finished with the intro. So let's jump into the basic packet capture here. So you can run TCPDump without providing any arguments. So basically just type TCPDump and press enter. But this is only useful to test that you actually have it installed. In any real case scenario, we have to be specific about what we want to listen to, where we want to write the data to, and how to actually display the packets that are going to be captured, right? Specifying the interface would be done with the I flag, or the I option. So it would be -I, and then you could say any to capture traffic from any interface, or you could actually choose a specific interface. For example, if we do IPAS, which is essentially the list of IP addresses that would be on our system, we would get a couple that would show up, and then for each one of them, there's some kind of a interface as well. So the LO interface is available pretty much on every computer, and that would be the local, aka the loopback interface. By the way, if you hear like buzzing in the background, there's like a massive windstorm that's going on right here, and it's kind of crazy. Like, I don't know if you could actually hear all the wind that's going on outside, but I feel like I'm recording in the middle of a freaking hurricane or something. It's pretty insane. Okay, so yeah, the LO is available on every computer. It's typically the loopback or the local address, and for that, the IP address is always going to be 127.0.0.1, and that's for the most part on every machine that I've ran this command on. That exists on every single machine. So this is not what we're trying to really connect to or capture traffic for. What we are interested in is the actual interface. So in this case, it's ENS5. And then the IP address for this is 10.10.20.253. And if we go to the top of my screen right here, that's the IP address that's been assigned to me, 10.10.20.253. So that's my temporary IP address for this virtual machine that we're using. So you could do ifconfig. You could also do IP. Oh, I guess ifconfig doesn't. It's not installed on this particular machine, so you cannot do ifconfig on this machine. Typically, you could be able to do ifconfig, and it would still essentially list the same thing that you would see over here. In this case, it would be IP-A-S, which is basically listing the available network interfaces, and it's like an acronym for IP address show, right? So that's basically what we would do. So I could actually do IP address show, and it would give me the same response, right? It's just the acronym version, the shortened version, in case you're lazy like the rest of us inside of the tech community. Believe it or not, tech people and programming people, like, they're actually super lazy. That's why they learn programming, because they want to shorten the process to do things. Anyways, whatever. All right, so now we have our interface, right? So what we want to do is we want to save the captured packets in this case. And you want to use the -w command to write something, right? So the extension is most commonly set to .pcap, which is the packet capture file extension, which is typically what we use with, Wireshark, or really any kind of packet capture file is ending with pcap. So that's how I recognize it, and I feel like everybody else also recognizes it that way. The saved packets can be inspected later using another program like Wireshark, which we did in the last video. You will not see packets scrolling when you use the -w option because it's being written to the pcap file that you have designated. It won't display onto the screen, which can actually be very useful. So reading the packet capture from a file would be done with the -r. So when you do TCPDump, you can do the -r and then give it the file name, and now you're in read mode, and now you're reading the file. And then you can limit the number of the captured packets by using the -c and then giving it a count. So for example, if you do -c10, it will capture 10 packets, right? Don't resolve the IP address and port numbers. If you don't want to do that, that is done with the -n. And so this is avoid making such DNS lookups. You can actually use the -n argument, which basically means just show me IP addresses. I don't want to know the DNS resolutions or domain name service resolutions. I just want to see IP addresses. That's basically what we're doing here. If you don't want port numbers to resolve, you can use the -nn. Right, so if you don't want to see 80 being resolved to HTTP, you just want to see port 80, right? Then you would do -nn. And then so when you do -nn, it stops both the DNS resolve as well as the port number resolve. So you only see IP addresses, and then you actually see the port number. And then so this is what the command, for example, a combined command would look like. We're using sudo because we want to use admin privileges, root privileges, then TCPDump. We're going to capture it on the ENS5 interface. We want to count to 5, and then we don't want to see the IP addresses resolved to actual DNS, to domain names or host names or anything like that. We just want to see the IP address, and then from there, that's basically it. You just press enter, and then it captured 5 packets, 1, 2, 3, 4, 5, and then it showed us the information. It goes from this IP, it's going to this IP, and then it's going to that's very interesting. I would say that this is the port number at the very end of it. And then what else do we have that's interesting? So we have, these are a couple of acknowledgments, it seems. The options, let's see. Yeah, I mean, not much really. It doesn't really show much. It's just saying that there's IP addresses. The same IP address is pinging essentially the next IP address, and it's just acknowledgement packets, it looks like, that's sending out. And I may not. Yeah, that's basically it. I don't think I'm missing anything with that, honestly. If you wanted a more verbose output, you could actually do -v. If you wanted very verbose, you would do -vv. And if you very, very verbose, you would do vvv. And it would give you more verbosity, which I love. That's like a really fun word. And verbose basically displays more on your screen compared to the last thing. To the last command. So I would say the best way to actually display this to you, to actually show this to you, is for me to actually run this. So I will do TCPDump, and I will do it on my ENS5 interface, which is what I got. And then we're going to limit it to 5. And then we're just going to also do the -n just for its and giggles. It says use the sudo password for the user, which is what we had actually over here, which I guess is going to be THM123. And there we go. All right, so we got our packets, and they've been captured. And this is basically what it looks like. The first one is this. It's going from 1010 to NT253 on port 22. It's going to this IP address, and it's going from this one to this one, and then going to this one again to this one, and then from this one to this one, etc. It's just a back and forth between 2 IP addresses, essentially. They're not one per line, so if I actually open this up in a new window, we'll probably see a better view of this. And this actually cleared it up again. So let me see if it saved my command. It didn't. So I will do sudo TCPDump interface ENS5, and then we will do what was it, N, and then we're going to count to 5 packets, and then THM123, And there we go. All right, so this one's a little bit cleaner because now you actually get to see one per line, so it's a little bit easier to actually read. So the first two are going from the 253.22 to 130 or 130, and then 130 is responding to 253 to 22, and then this one is sending another 2 packets, and that's basically it. Like it's really not much that's happening over here, and we try to see. I mean, I could technically like copy and paste this inside of Gemini and be like, break this down for me line by line. But for the most part, there's nothing interesting inside any of these packets for me to be like, oh, that's what this is. So it's essentially a communication going back and forth, and they look like pings. They look like basic acknowledgement requests or sequence requests, and that's basically it. I cannot find anything that's fascinating in it. Maybe if you're way better at reading these traffic lines than I am, maybe you can drop it in the comments and kind of what is it, enlighten us. That's the word that I was looking for. The thing that I wanted to show you though is if we did verbose at the end of this, right? So if we do dash VVV, so I'll do super verbose, right? Press enter, and then we can see that there's per line. Now you can see that there's more stuff coming out per line, right? So I still have actually not before that even starts, the very top of this TCP dump listening on link time 24 bytes, TCP dump verbose output suppressed, use V for output, listening on and capture size. So just from the top, that's actually different from the previous output that we got. And then we're actually now getting an extra layer of content that's coming out, as well as the IP addresses that are communicating with each other. Now there's a flag, there's a checksum, incorrect, sequence number, acknowledgement. What else do we got? There's clearly more options that are available that have been printed onto the screen. And that's basically what verbose does. It just gives you more of an output, more details for you to analyze, just in case you're really getting off on details, right? Like just in case you really like details. So these are our little cheat sheets for running commands with TCPDump. We have the -I giving us an interface, -W to write it onto a file, -R to read from a file, -C to count it, -N to not resolve the DNS, and then -NN to also not resolve. So the first N is DNS, the second N is the port number, and then -V gives us the verbose output. So looking at these things right here. So on the interface ETH0, counting the 50 or counting up to 50 packets captured and getting a verbose output. And then we have interface WLO1, and then writing into the data PCAP file, and then any kind of interface without any domain name resolution or port resolution. These are the potential examples that you could run with TCPDump. Now it says, which option can you add to your command to display addresses only in numeric format? And that would be the -N, because we don't want to resolve the name. If you want to remember it that way, you don't want to resolve a name, you just want the number is what you're interested in. All right, so that was it. We just ran our first couple of TCPDump packet captures, and we did not output them onto a file. I guess I could technically output it onto a file just for giggles, right? So if we write ls, oh, we already have a PCAP file over here, so I can actually do TCPDump, and I can do it in read mode and do traffic.pcap, and then let's see. Oh my God, look at all that! Holy cow! This is what is inside of that oh my gosh, this thing is still going. All right, we're gonna stop. We're gonna stop reading that. Stop reading it. Control C. Okay, very good. Look at all this output. That one freaking PCAP file. Look at all this output. I mean, there's so much that I literally ran out of space and I can't scroll up. That is insane amount of output. We're probably going to use that for an exercise later on to try to capture some data or try to find some data through that massive freaking output file. That was ginormous. All right, anyways, let's now use expressions to filter. So we're going to use probably regular expressions to actually filter the packets that we are going to get. And let's see what we can learn from that. Okay, so you can run TCPDump without providing any filtering expressions. It's not going to be useful. So what you just saw is what we did without any filtering expressions. Just like in a social gathering, you don't try to listen to everyone at the same time. You would rather give your attention to a specific person, or at least a conversation between a couple of people. Considering the number of packets seen by our network card, it is impossible to see everything all at once. We need to be specific and capture what we are interested in inspecting. So if you wanted to filter by host, for example, we could use the host option, right? And this is not a dash host, this is just host. So this is what the command looks like: sudo TCPDump host, and then in this case we're actually using the domain name and then doing a write to the pcap file, right? You could also do this by IP address. So instead of doing domain name, you could basically just do host and then provide the IP address and then write it to the pcap file. That's exactly what this command is actually displaying for us. And then you can see that example.com in this particular case, it's not showing us what the conversation is between these guys, but for the most part, we can see that maybe if it's ending in the .http, that would be presumed to be example.com's IP address on port 80. That's what HTTP is. And then that's what the conversation looks like. And then can we see anything else over here? No, there's nothing else over here that would give us any kind of a hint that that's example.com. The only thing that I can understand, or the only thing that I can kind of deduce, is that when it ends in the .http, it's assuming, or it's implying that it's sitting on port 80. So we're communicating with this particular IP address on port 80, which is HTTP, which is the communication that you would do with a website. And so that is the implying, right? That's the implication that we're talking to example.com in this conversation. So if you want to limit the packets to choose from a particular source IP address or hostname, you must use the source host and then give it the IP, or source host hostname. And similarly, you can limit packets to the destination by using DST host IP or the hostname. And so you're obviously, this is the abbreviated version of it. So SRC and DST would represent source and destination respectively. You can also do a filter by port. So if you wanted to do a port filter, you would just do port and then give it the filter, right? The number of the port that you actually want to capture. And in this case, the port 53 is our DNS port. It is the default port for DNS. And so sudo TCPDump interface ENS5 on port 53, and then don't resolve by the name, just show me the IP addresses, and now we can see it, right? So this is going with any direction of conversation. So this is the source, it's going to destination on port 53, and then same thing over here. And then now the source is port 53 coming and talking to this same guy right here, and then second line, same thing. And then we have two conversations going on, right? So example.org, and then the response from example.org, I would say. And this one is getting the quad A record as well as the A record. And the A record would represent IPv4, and then quad A would represent IPv6. This is stuff that we talked about when we were going through the networking basics, the fundamentals of it. And so when you send that request of saying, hey, send me your IPv4 and your IPv6, then the IP address for example.com responds to us and says, this is my IPv4 address, and then this is my IPv6 address. And look at that, that's a massive freaking IP address. IPv6, it's just mind-boggling how much longer and more complicated it looks like than IPv4. And that's pretty much it. So that's all we got for this particular packet capture. And so in the example, we captured all the packets from a specific port number, port 53. You can obviously go source port number, and destination port number as well. And then we can now go filter by protocol. So if you wanted to filter by protocol, you could actually do IP, IPv6, or just IP6. You can do UDP, user datagram. You can do TCP, transmission control, or ICMP, which is the Internet Control Messenger Protocol, I want to say. In the example below, we limit our packet capture to ICMP packets. And then there's an echo request and reply that's happening, possible indication that someone is running the ping command. There's also an ICMP time exceeded due to running the traceroute command as explained in Networking Essentials. So this is what it looks like right here. TCPDump on the interface, ICMP is the only protocol that we want to capture, and then we can see the responses right here. So you can actually see that these these line items for this traffic capture, and as well as the last one that we did when we were trying to get the A and the quad A records, it actually has a little bit more information for us to be able to analyze. For example, this actually says this is an ICMP echo request, which is essentially another way of saying this is a ping. This is an ICMP echo reply, which is another way of saying that this actually pinged back. And then time exceeded in transit could be technically trace route, which is the calculating the number of hops that something takes to go from its destination to, or from its source to its destination. That's typically what we see when we see time exceeded. Usually if it's down, and if like the server that you're trying to connect to is down and you can't connect to it, you would get either a time exceeded, or the response from ping is something like it couldn't be resolved or something like that. I don't think ping, if ping fails, I don't think it gives you a time exceeded. I think time exceeded is actually specific to traceroute. So that's how they kind of determined that that's what these two packets are, and then these are actual ping requests and replies. But yeah, that's basically it. This is the example to show you that you can use a specific protocol to filter for as you are doing your TCP dump capture. And then we actually have logical operators, which become very, very useful. So you have and, or, and then not. So and combines these two, right? So if we say I want to capture on this host and I want to capture on the TCP protocol, it would do everything that has to do with that host and the TCP, right? So when you use the keyword and, or the operator and, both of these conditions have to be true in order for the response to come, in order for the conversations to be filtered, right? If you did or, and then so you do TCP dump UDP or ICMP, then it will show you anything that has to do with UDP and anything that has to do with ICMP. If you did UDP and ICMP, which I guess technically won't work because you can only have one protocol, so that won't work. But essentially when you add or, you're filtering for both of these things, and you're going to get a much, for the most part, you would get a much larger output than if you just did UDP, for example, right? So when you do or, you're adding both of these to the list, and then you're going to get either one, right? Either or. Show me anything that has to do with either or of those two. And then not means that I don't want to see TCP, right? In this particular case, we're saying show me anything that is not TCP. So anything other than TCP is what I want to see. For example, it could be UDP, ICMP, it could be ARP packets. It could be anything that would come back that is not TCP. As long as it's not TCP, I want to see it. That's basically what we're saying. So these are summaries and commands here. TCP host IP, TCP dump host name, and then we have TCP dump source host or destination host, and then TCP dump port number, source port or destination port, and then we have the TCP dump as well as the protocol, for example, IP or IPv6, ICMP, so on and so forth. Now, these are some examples of combining some of these options together. So we say, show it to me on any interface, and then show me only TCP conversations that have to do with port 22. This is what this whole thing is going to show us. And port 22 has to do with secure shell, because that is the default port for secure shell. And then I want to see everything that is on the WLO interface. I want it to be a UDP protocol, and I want it to be on port 123, port 123, which is the NTP port, so the network time protocol. And that, I think that actually just gives you just the time, like the date and time kind of a thing. Then we have TCP. Don't quote me on this. Let's actually click on it. It'll tell us. It says it's a networking protocol designed to synchronize the clocks of the computer over a network. It uses a designated reference time source, such as the atomic or GPS clock, to coordinate the system time for all network devices, and ensures that all computers within the network have the same accurate time, which is crucial for various applications, including logging, security, and data integrity. So it does not show you the time. It synchronizes the time. So big mistake right there. I hope you didn't listen to the first part of that sentence and skip. I hope you actually got the explanation for what network time protocol does. And we have TCP dump This is a much longer command. So we have TCPDump on the ETH0 interface. The host that we're filtering for is example.com. And we want it to be on TCP port 443, meaning HTTPS. And then we wanted to write it to the https.pcap file. So it's going to listen on this interface. It's going to filter for the example.com domain name. And it's going to filter for the TCP protocol on port 443. And then we're going to write everything onto that pcap file. So for the questions from this task, we will read captured from this thing right here, traffic.pcap, that massive file. As mentioned earlier, you can use the -r to read it. Then we're going to read it and then count 5 of the packets because there are just too many damn packets. It should display the first 5 packets in the file without looking up the IP address. Remember, you can count the lines by piping the output via the WC command. In the terminal below, we can see that we have 910 packets with the source IP address set to 192. Please note that adding the N to avoid unnecessary delays in attempting to resolve IP addresses. In the example below, we didn't use sudo as well as reading from the file does not require root privileges. So basically what they did was they read this file, they looked for this source host, and then they did not resolve it, and then they just did word count. And word count just counts the number of lines by default. And so there was a 910 just about this freaking IP address. So obviously it's a massive file. If you're just looking for one IP address and then you have 910 records, yeah, that's a massive file. So questions here. How many packets in traffic PCAP use the ICMP protocol? So this is what we're going to do. We will go here actually, and then we will do TCPDump. Let me see if my keyboard is even working. TCPDump -r and then traffic.pcap. And then what we want to do is ICMP is what we're doing, right? That's it, right? ICMP protocol. And then that's basically it. And then what I'm going to do is I'm going to do the word count. And then I'll actually, hold on, I'll do -n so it doesn't resolve the names. And then we'll do word count, press enter. And then it says 26. So the first number here is, I believe, the number that we're looking for. So we will run 26, and that is indeed the right answer. Beautiful. That's the command that we ran. So just so you know, in case you're trying to find this answer yourself, it is TCPDump -r and then reading the traffic PCAP file. We're looking for the ICMP protocol. -n would be to not resolve the names so that it saves us a little bit of computing power. And then using that vertical pipe right there, which if you, it's the, for my keyboard, it's the button that's right above my enter button. And if you hold down shift and then you press that, you will pipe it, and then you pipe it to the word count, and it counts the number of lines, and then it gives us 26. All right, very good. What is the IP address of the host that asked for the MAC address of 192.168, so on and so forth? So the IP address of the host that asked for the MAC address of this. Now the MAC address is the ARP protocol. So we're going to look for ARP protocol, and then we're going to search for this host, and I think we should be able to find it with that. So let's do this. We'll do TCPDump -r and then traffic.pcap, and then we're going to do ARP because we want the ARP protocol, and then we're going to do the host, and then we're going to do this thing. Let me see if I can copy paste inside of this. That would be very clutch if I could. I could. Very good. Okay. And I think that's it. And I'll just do -n to not resolve anything. Press enter. And then we got 2 ARP requests. That's all we got, which is very useful. Out of that massive file, there's only 2 ARP requests. So it says who has this IP address? Tell this IP address. So this is the guy that is trying to find out. Can I copy this? Okay, there we go. I think I copied it. So if I go here and paste it, I think that should work, right? Sweet. Nice. Very good. Now, what hostname subdomain appears in the first DNS query? So we're going to filter by DNS as our protocol, and then we're just going to count because I don't know how many of them there are going to be. So I'm just going to count the top 5. And then we will get the subdomain, hostname subdomain, and I mean that should be it. It's like something I think. So let's see. So if we're going to go back here, and the last one that we ran, I didn't review it with you, but this is the last one that I ran, TCPDump-R. Basically, this part is going to stay the same every time because we're reading from the PCAP file. We looked for the ARP protocol because that's the address resolution protocol that searches for a MAC address. And then we went by the host of this particular host because that's the one that we want to see who's asking for this host. And then I did not resolve the names. So it would only give me IP addresses, and then there was only 2 records that showed up. Now the next one that we want to do is TCPDump, which is going to read again from the traffic.pcap file. In this case, we're going to do DNS, and we're just going to count it to 5, and then that's it, really. I'm just going to press enter, and it says can't parse filter expression, syntax error. Did I do something wrong? What did I do wrong? Let's see, what's the question? What host name appears in the first DNS query? I thought I did it right. Let me see. Okay, so basically another way to do this, which I literally sometimes when I make these mistakes, I'm like, dude, what? It's so simple. We're just gonna do port 53 because that's the port for DNS, and I'm just gonna count 5, and then let's see what we got. So on port 53, and then what's the question again? What hostname subdomain appears in the first DNS query? So if I go to the hostname subdomain, that shows up in the first DNS query. I believe it's the compute internal.domain. No, actually, it's right here. It's the mirrors.rockylinux.org. So if I just do that, that should have copied it. Sweet. There you go. Just like that. Just like that. Easy money. Easy. All right, cool. All right, we have now filtered expressions. Now let's do some advanced filtering. Ooh. All right. So there are many more ways to filter packets. After all, in any real life situation, we would need to filter through thousands or even millions of packets. It is indispensable to be able to express the exact packets to display. For example, we can limit the displayed packets to those smaller or larger than a certain length. So greater length filters packets that have a length greater than or equal to the specified length, and then same thing, less than or equal to the specified length. So you can check the PCAP filter manual page by issuing the command man PCAP filter. However, for the purposes of this room, we're going to focus on one advanced option that allows you to filter packets based on the TCP flags. Understanding the TCP flags will make it easy to build on this knowledge and master more advanced filtering techniques. So what do we have? Before proceeding, it's worth visiting binary oh my god. Okay, binary operators, bro. This is, I need to take off this mask off the top of my head just to give my head a little bit of breathing room here. A binary operation works on bits, meaning zeros and ones. An operation takes 1 or 2 bits and then returns 1 bit. Let's explain it more in depth and consider the following 3 binary operations: and, the pipe, and then the exclamation. So and, ampersand, takes 2 bits and returns 0 unless both inputs are 1, as shown in the table below. Okay, my god. So input 1 is 0, input 2 is 0, so inputs 1 and input 2 will end up being 0. Input 1 is 0, input 2 is 1, input 1 and input 2 combined would be 0, and then 1 and 0 would also be 0, and then 1 and 1 will end up being 1. Okay, so the way that I'm processing this, I try to look for patterns. The way that I process it is that if, and I don't know if this is right, okay, so this may be completely wrong, and we're about to find out if I'm right or wrong, but 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. And then 1 times 1 is 1. That's the pattern that I noticed. Now, I don't know if that's actually the correct pattern or the way to read this, but that's basically all I got. Because I know it's not addition. 0 plus 1 would actually be 1. So I know that's not addition. It would be, I would say, multiplication. So now, the pipe. Let's go down here again. So the pipe. or the OR option, I guess. It takes 2 bits and then returns 1. So takes 2 bits, returns 0 unless both inputs are 1. This takes 2 bits and returns 1 unless both inputs are 0. So basically the inverse of this whole thing. So if we do 0 and 0, it's 0. 0 and 1 is 1. 1 and 0 is 1. And then 1 and 1 is 1. This one I have no pattern for. It takes 2 bits and returns 1 unless both inputs are 0. So that's basically the only thing that I can. And then this takes 2 bits and returns 0 unless both inputs are 1. So basically this one, from what I'm understanding, if as long as both of the inputs are 1, that's the only place that you'll get a response of 1. Apart from that, doesn't matter essentially what the inputs are, it will always return 0. That's if you're doing ampersand. If you're doing the pipe or the OR, then it'll take 2 bits and it will return 1 unless both of them are actually 0. So it's literally the opposite of this. So 0 and 0 would end up being 0. Every other option will end up actually giving you 1. And then we have the not, so the exclamation mark. It'll take 1 bit and then it inverts it. And input of 1 will give you a 0, and input of 0 will give you a 1. And this one is basically it. This is like it's a much simpler, it seems to be a much simpler pattern to recognize. Binary, bro. Jeez Louise. All right, okay, very good. Header bytes. The purpose of this section is to be able to filter packets based on the contents of a header byte. Consider the following protocols: the ARP, Ethernet, ICMP, IP, TCP, and UDP. There are just a few networking protocols we have studied. How can we tell TCPDump to filter packets based on the contents of the protocol header byte? We will not go into the details about the headers of each protocol, as this is beyond the scope of this room. Instead, we will focus on the TCP flags. So, using PCAP filter, the TCPDump allows you to refer to the contents of any byte in the header using the following syntax: the proto, and then inside of the square brackets, you would have the expression and then the size. So proto refers to the protocol, for example, whatever the protocol is that you've chosen. And then these all refer to ARP, ICMP, IPv4, and what is it? ARP, excuse me, yeah, so ARP, Ethernet, so ARP, Ethernet, ICMP, IPv4, IPv6, and then TCP, and then UDP respectively. Expression indicates the byte offset, where 0 refers to the first byte, and then size indicates the number of bytes that interest us, which can be 1, 2, or 4. It is optional and is 1 by default. To better understand this, consider the following 2 examples from the PCAP filter manual page. Don't worry if you find it difficult. Okay, so I feel like that was for me. That literally, that piece of instruction was talking to me. They're like, yeah, don't worry about it. If you don't get it, don't worry about it. Don't. I'm gonna try to get it, but if I don't get it, don't worry about it. That's basically what they're telling me right now. Okay, so ether 0 and 1 does not equal 0. So it takes the first byte in the Ethernet header, which starts with 0, right? So that's what they say. So the 0 refers to the first byte. So it takes the first byte in the Ethernet header and the decimal number 1, so and 1, for example, quad 0 and then 0001 in binary, and applies the and, okay, the and binary option. It will return true if the result is not equal to the number. So for example, if this obviously is not equal to this thing. So we're looking at Ethernet byte 1 and the number 1, right? So we're looking at the decimal 1. And then so if it does not equal to 0, then it's going to return true. The purpose of this filter is to show packets sent to a multicast address. A multicast Ethernet address is a particular address that identifies a group of devices intended to receive the same data. IP0, looking at the first byte of the IP, and compares it with the hexadecimal number of F, which in binary is this. It will return true if the result is not equal to the decimal number 5, which is this. I'm like losing my shit. I kind of get it actually. I kind of get the uh the the pattern. It feels like I'm kind of understanding it. So this is the IP protocol, the first byte of the IP protocol, and then we're looking at this is the hexadecimal for the character, for the number F, I guess, then hexadecimal number F, which is this would be the pattern for hexadecimal number F. So if this byte is not equal to that, not equal to 5, which would be this, then it would return true. I think. I don't know if I wrap my head around that well enough. I'm so sorry if I'm not explaining this correctly, because I also am having a tough time wrapping my head around it. So if you're as confused as I am, I guess that's okay, because they said don't worry if it's too difficult or whatever. I don't know why they would do this to us if we shouldn't worry if it's difficult. It's like, well, why are you doing this to us? Like, it feels like it's torture. Don't worry if you find the above two examples complex. We included them so you know what you can achieve with this. However, fully understanding the above examples is not necessary to finish this task. Instead, we will focus on filtering TCP packets based on the set TCP flags. Look at this. This is so much easier. I recognize all of these. So you can use the TCP and then the TCP flag to refer to the TCP flags field. These are the flags that are available. So this is the synchronize, this is the acknowledge, this is the finish, this is the reset, and this is the push. So much easier than this shit right here. Excuse my French. Based on the above, we can write this TCP dump, and then look at this TCP flag. So that's the option essentially. This is what you would have to declare, and then you say that you want it to equal to the SYN flag. So TCP, and then looking for the TCP flags, that's the pattern that we're choosing. And then from here, we want the pattern to actually equal to the SYN flag. And then TCP dump, again, TCP flags and TCP SYN does not equal to 0, right? So it does not equal the capture TCP flags with at least the SYN, synchronize, being set. So in this particular case, 0 would be false and then 1 would be true. So with at least the SYN is being set, that is what this means, is that it's not 0, meaning it is 1. That's what I'm concluding from that. And then TCP flags and TCP SYN and TCP acknowledge are not 0, meaning at least the SYN and acknowledge are set. So that would be the way that we can filter using these advanced filtering options. Okay, so now let's see if we can actually get the answers to these. How many packets have only the TCP reset flag set? So I'm actually going to use this thing so I can use the examples that we have on the right side over here. So we want, we're going to do TCP dump, and then I'm guessing we're reading the packet, right? So TCP dump r traffic.pcap. I think that's what we're supposed to be reading to be able to find this. So how many packets have that set? And then what we're looking for is this. We're going to do a quotation, we're going to do TCP, and then we're going to do these square brackets. And we're going to say TCP flags, and then close the square brackets. And we just want the flag to be set. So we're going to do and, the ampersand, and then TCP RST, so TCP-RST is going to be not equal to, so exclamation equal 0, meaning it is set, right? So it wants the TCP reset flag to be set. This is the acronym for TCP reset right here. So it would look like just like this, except we're just changing it from SYN to RST. And then that's what the command would look like right here, assuming that we're supposed to be reading the PCAP file right here. That's what the command would look like. So let's press enter. Oh, I forgot to count it. Goodness gracious. That seems like a lot of packets. Yeah, that doesn't look like that's the answer. Let's end that. Can you stop? Can you stop, please? Thank you. All right, so let's do that one more time. And I'm going to TCP flags, right? And then TCP RST is set. That's basically what it would be. And then how many packets have only that set? It doesn't tell me what interface I'm supposed to be reading from or any of that stuff. So that's the piece that's kind of confusing for me. Maybe we're just supposed to run it on our current interface. That's kind of what I'm gathering from this, because apart from that, I have no idea what else is the option for me to be reading from. Okay, so instead of doing this, I'm just going to pipe this into word count and let's see what we get. And that's 65,598. So that's definitely not the one that I am trying to read, because that is a massive output. So I'm going to do just TCP dump by itself. And then I'm going to just write the rest of the options right here real quick. All right, so that is the command, and I'm not reading from the pcap file. I'm just running basically this thing, and then with the RST packet set. So this is what the new command actually looks like here. TCP dump, TCP flags right here, and TCP RST is not 0, meaning it is set. Press enter, and it says you don't have permission to capture on that device. Oh, I need to do sudo. Goodness gracious. Okay, let's do that one more time. Okay, here we go. And I will actually pipe that into the word count as well. And then we need the password. All right, so that is the mistake that I made, was that I was trying to actually filter for this flag being set when I was just literally supposed to just be like, okay, I only want to see the ones that actually have reset set. So TCP dump, read the traffic file, and then we're going to do TCP flags right here. Same, this part stays the same, right? And then we're just going to say is equal to TCP-RST, and then pipe that into word count so we can see the number of packets, and then we can see that it's 57. So that's a much smaller number, much more manageable, and that is indeed the right answer. Okay, so now the next question is, what is the IP address of the host that sent packets larger than 15,000 bytes? And so we're just going to essentially read again, but then we're just going to use greater than 15,000, right? So we're going to do TCP dump. Again, we're going to read from the traffic.pcap, and then we're just going to say greater than 15, 1, 2, 3. And oh crap, I forgot to count it. So we're just going to let me clear this. I'll go up, and then we'll just rerun that, and we'll just count it. It says 56, right? Or, oh, what's the IP address of the host that sent packets larger than 15,000 bytes? Okay. I was actually supposed to do that. Okay, that it sent packets. And then I was supposed to also do the end so it doesn't resolve the name. Man. A lot of stuff. Okay, so if I am correct about this, because all of the IP addresses that are sending are exactly the same. So 185.117.80.53. And that would be the one. So 185.117.80.53. And that is indeed the right answer. So just to show you what the final command for that looked like, it was this thing right here. Let's zoom in a little bit. This is the final command, TCP dump, read from the traffic file, greater than 15,000, and then just -n. So it doesn't resolve the name for me. I just want to see the IP address. And that was indeed the answer that we found over here. So excellent. Now we can move on to displaying packets. So let's see what we can learn here. All right, as you can imagine, there are a lot of different options for displaying packets. The ones that we're going to be talking about are these options right here. So the -Q would be the quick output, which prints brief packet information. -E would be the link level header. -A would be the packet data in ASCII. -XX, lower x's, dos Equis, shows the packet data in hexadecimal format referred to as hex. And then a capital X shows packet headers and data in hex and ASCII. So to demonstrate how this would look like, we would read from the two pcaps, or two packets.pcap, I guess. So the above options manipulate the output. First, we'll display two captured packets without using any additional arguments. And so this is what it will look like if you were just doing two packets without any additional arguments. That's what it looks like. Now, if we wanted to get the brief packet information, we just do -Q, and then you can see that it's literally it's like so small compared to what this is, right? So again, the starts the same, HTTPS. This one is HTTPS. It's going to this, right? It's going to this TCP25. And I mean, you have to go a ways to be able to find that TCP25, which is, nope, it's at the very end. So you see length 25, and then I guess we see TCP at some point. Do we even see TCP over here? We don't. We don't even see TCP over here. So it doesn't tell us that it's a TCP packet. It just tells us that the length is 25 at the very end of that. Over here, it says it's a TCP packet and it's 25. I'm assuming that's the length. And then same thing over here, much shorter version, right? So this is the quick version. Shows the timestamp along with the source and destination IP and the source and destination port numbers. So these are the port numbers. So that's what it is. Source destination IP. And then I'm guessing these are the source destination. No, it's not. These would be the port numbers, right? Unless I'm misreading this. Anyways, link level header would be done with the -E. And so it gives us the, let's see, if you're on Ethernet or Wi-Fi network and want to include MAC addresses in TCPDump output, all you need to do is add the -E. It's convenient when you're learning how specific protocols like ARP and DHCP function. It can also help you track the source of any unusual packets on your network, meaning trying to find the actual MAC address that is connected to the IP address that is sending these weird packets. So these are the MAC addresses that we can see right here. And then these are the destination MAC addresses that we can see right here. Ethernet types we have over here, the lengths of the packets. And then these are the IP addresses, as well as the, I guess, the resolved names, because we haven't done a -N to not resolve the names. So this is giving us the link level header. And then the data link layer is what this is referring to. If you think about the ISO 7 layers, this is what that is referring to, is the link level layer, the data link layer. Displaying packets as ASCII, this is very, very different from what you just saw. As you can tell, there's some extra data that's going on over here. For example, these pieces are the ASCII layers of this. So the American Standard Code for Information Interchange is ASCII. It represents text. In other words, you can expect this to display all bytes mapped to English letters, numbers, and symbols, as you can see over here. So by is one of those, I guess. Displaying in hexadecimal format looks very, very different as well. And what we have here, ASCII works well when packets' contents are plain text English. It won't work if the contents have undergone encryption or even compression. Furthermore, it won't work for languages that don't use English alphabet. Hence, we need another way to display packet contents regardless of format. Being 8 bits, any octet can be displayed as 2 hexadecimal digits. Each hexadecimal digit represents 4 bits. To display the packets in hexadecimal, we must add the -XX, and you can see that over here. And so each 2 of these represent a letter, right? So that's what they said, right? It won't work, being 8 bits, any octet can be displayed as 2 digits. So yeah, this is what we see right here. So if we wanted to see what these are, for example, we could go ahead and Google hexadecimal to text, and then hex to text is what we will see over here. And if I do 02 and then convert it, what would give me? Okay, maybe 02 is too short, so we'll do this whole thing. I'll just take this block right here. Let's see if I can convert this to text at all. Oh, whoops. Convert that. I mean, it didn't convert to text, but it kind of did. So in a way it worked. But basically you can do that with with the use of a fairly simple online converter. And then if you wanted to see hexadecimal, you would just do -XX. That's all I gotta say, right? And then $X would give you the ASCII as well as the hexadecimal. And you know what? This is actually pretty close, because EM at 5 something something. That's kind of what this looks like right here. Oh, no, it's not. What am I saying? It's not even remotely close. Never mind. My bad, guys. My bad. So these are what they look like. -Q, -E, -A, -dos X, and -X. And then we got those. So what is the MAC address of the host that sent an ARP request? So the host that sent an ARP request, the MAC address of the host that sent an ARP request. I mean, there's a lot of them. Is it supposed to be from the traffic PCAP that I read? Okay, so if we went over here and let's read it. Yeah, it's just a massive amount of data. That's definitely not gonna work. So is there a hint for me? There's no hint for me. So I have to try to figure out exactly which one I'm trying to look for. Or is it the one, maybe it's the one from what we saw here of the host that sent an ARP request. So maybe this is the one that we actually are referring to here. The one that sent the ARP request would be the one at the top, I believe. That's the one that sent the request. So this would be the MAC address of the one that sent the request. I think that's what we're referring to here. Nope, that is not the one. All right, so it's neither of these, which tells me that we actually do have to read that big PCAP file. So let's see if we can try to craft a message here or a command that would actually work. So ARP is what we want, and then we're gonna do the -E because it's gonna give us including MAC addresses. So we're gonna press enter here. Oh, okay, so it is much smaller. That is actually a very nice output. So we want the one that sent the request, which is the first one, I would say. So let's copy that and see. Let's see if that's the one. Cool, that was the one. Okay, excellent. So that's the main difference here. That is what we had to do, is we just had to specify that we are using the ARP protocol, or we're searching for the ARP protocol. And then we did -E so it can show us the actual Ethernet MAC addresses. And that was it. Just like that, we are officially done with this. So let's see what the conclusion is going to say. The conclusion says absolutely nothing. It just says we've covered various TCPDump options. Congratulations. So along with Wireshark and Tshark, TCPDump is an excellent tool for better understanding of networking protocols. And you're officially done. Look at that, we're done. Congratulations if you made it to this one. And if you made it to the end, I hope you actually got some value out of this. If you did indeed get value from this video, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And we are still in the CySec101 series. I just finished Security Plus, and that's going to be going up, and I think on the 9th. I'm recording this on the 7th, I believe. And since that is actually done and it's been published, we can now run back into CySec101. And then there's also the AI cybersecurity series that's going to be coming out that I'm super excited about, because I personally think that it's the future. Everybody needs to know how to train AI, and you need to know how to integrate with AI. And I think that's one of the most powerful skills that you can develop. So that's going to be the next major training series that we're going to probably do, because that's what the community has been voting on over the last couple of days. So if you have not done so already, make sure that you like, subscribe, turn on that notification bell so that you get notified the next time that a comment comes up, that a content comes out, and then drop a comment. That's what I was trying to say. I kind of got ahead of myself. Drop a comment. Let me know if you had any questions. Let me know if there's something that you are curious about that you would like to see some videos on. And the AI thing is actually something that we actually got from a vote inside of the community, which is something that I did on this day right here. Hey, for the next major series, I want to see what's going on. And so far there's been 127 votes, and the AI for cybersecurity is currently leading. The other option was the Certified Ethical Hacker course that is available through Cisco, and that's getting a lot of votes as well. So it's kind of a very close, usually one option blows out the other option. This one is actually kind of close, so I feel like I'm probably going to do both of them. But I'm personally interested on AI and cybersecurity. So again, just make sure that you stay tuned. Make sure you like, subscribe, turn on notification bell, all that good stuff, so that you get notified the next time that a video comes out, especially in the CySec101 series, especially in basically everything else that we're going to be doing. So if you have not done so already, make sure you do all of those things. Like, subscribe, turn on notification bell, drop a comment, all that good stuff. And then there's the Hackaholics Anonymous membership community, which is the premier YouTube community for security professionals and hackers. And as a part of that community, you get access to so many different types of perks, all the way from the cyber supporter, as well as going all the way up to the cyber master. There's, Discord servers for each level. There's going to be, when you get to the advanced levels, there's going to be exclusive content, exclusive downloads like Python automations every single month. We do live streams. There's so many things. So you can join through the link in the description below. well, you can join through the join button that's on our homepage. Just go to the homepage and click join. And of course, you can go to youtube.com/@HankHacksHackers/join, and you will be able to join the Hackaholics Anonymous community. I really hope to see you inside of the Discord server. If not, I hope to see you inside of the comment section on the channel. This is your boy Hank Hack, presented Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. And then you could actually even see my little puppies right here, sleeping right here. They're being all cute and quiet, which is very rare for them because they're usually raising up a freaking storm. But it's late at night and it's time for everybody to go to sleep. So time for me to go. I'm gonna go edit this real quick, publish it, and then I will see you in the next one. Peace.